And our last but not least speaker, Mladen Canovic, data scientist at Untitled Solution, and his topic for today is semantic segmentation of tennis match videos. Mladen Canovic is a data scientist in Untitled Solution from Serbia, where he began his journey in the field of data science, switching from software engineering. He graduated from the Faculty of Mathematics, University of Belgrade. Mladen is big on sports, and he will be presenting how he applied his knowledge by developing AI models that can analyze a large number of tennis match videos. This talk will be answering how different ML models can be used to extract additional information from these videos. Mladen?
Hello, everyone. My name is Mladen Canovic. Thank you all for joining. I'm really glad to be here. So, 15 years ago, I started playing tennis, and about 10 years ago, I was on the path of becoming a tennis coach. So then I used that knowledge in order to extract some relevant information from tennis match videos, as we will see today. So, yeah, we can start right now. I would first like to answer two questions. Why did we do this? And what did we actually do? So to answer the first question, why did we do it? So actually we had a collaboration with a professional tennis player, and during those conversations we detected some ways to assist tennis players generally to improve their game. So the main takeaway from those conversations was that they were lacking some video platform where they could analyze their game or their opponent's game easy, to skip some irrelevant parts of a tennis match and just to view some relevant parts of tennis match, some specific points, some critical points in the match. And what did we do? So I actually already said what did we want to do, and we have built a video platform where they could actually achieve what I mentioned before. So we can see here that we are able to, we have actually 4 categories of points. We can choose, user can choose a category, and then the platform will list all points of that category, and then the user can then choose a specific point, and then watch that specific point, as we can see here. This is one of my favorites. So, yeah. That move right there. Okay, and after we have segmented the match into points, we then wanted to see how can we achieve some achieve more, and we have implemented some action recognition methods. We can see here that we are able to detect court, to track players, to track ball, and to recognize which type of strokes are played. And we can see, we will see today how we achieved all that. So first, I will talk about match segmentation based on OCR. So we used OCR to analyze a match and to see when was the result active. So again, match segmentation, we have a match video, we want to split that match into timestamps and to be able to view specific points. And then we want to tag those points with specific categories like match point, forehand winner, ace, as we saw before. So first, we, of course, need to localize the scoreboard. I will talk about that later, but first I would like to mention that in order to get the current score on a frame, we can information about previous score can be really relevant, because we know that each tennis match starts from 0-0, and we can start building up from there. We know that at any point in time, the first player can win the point, the second player can win the point, or the point is still in play, so the score remains unchanged. So we detect the scoreboard. I'll talk about it later. We then use OCR to detect text on that localized scoreboard. Usually OCR comes with some errors, and we modify that using some simple heuristics, also by analyzing previous score. After we have modified the score, we then choose the most probable option for the next score. As we can see here, it is the score remains unchanged. And now, yeah, now about scoreboard localization. How do we do that? Well, you get n random frames from tennis match video, and then you localize the region which deviates the least, which is mostly there, which is mostly present in the video. So to answer that question immediately, you can have multiple regions where you can have some static text on the frame, like logo of broadcaster or something like that. And we also employ some regular expressions to detect whether it was a score or it was just some random text. After we have done that, we then need to detect the last thing to be able to have some proper segmentation system. We want to detect who serves when. So how did we do that? Again, we get some n random frames. Then we mask out the text regions on all those frames. And then we are left with just two bubbles, with just two groups of pixels, which are then our serve indicators. And to know who serves when, we only need to employ this method just once in the beginning. And then we use the rules of tennis to know, to deduce who serves in which point. OK. Yeah, I would like to note here that we labeled some matches using our stroke codes. And we have done that point by point, stroke by stroke, so each rally. But to do that, we have used first our tool to segment the match into single points. And then we have annotated those rallies. So it took us not much of a time. And it was not boring, definitely. So yeah. Again, we're back at our initial video. And I will skip that to action recognition. So again, as I said, once we segment the match into single points, we want to see what can we do else in that specific segments. So as we saw earlier, we are able to recognize strokes. We are able to detect whether it was a forehand, backhand, serve. Also, we are able to detect court, track player, track ball. And we can see that we will see how can we leverage all these methods in order to segment non-professional matches, which obviously doesn't include scoreboard on the screen. So we had to use some more advanced methods. And non-professional matches are played throughout all the world. So professional tennis matches are only a small % of tennis played globally. So yeah, this is also interesting to do. In order to develop our models, we first needed to have a data set, like a proper data set with videos that were representing each class of strokes we wanted to detect. As I said, forehand, backhand, and serve. And once we obtain many videos, we then want to transform those videos into some kind of action images. I'll talk about it later again. To explain what I mean by this. And on those action images, we will train a simple CNN, which will work just fine. Now, we have developed another model in order to automate labeling as much as we can, and also to investigate some other methods we can use on this specific type of problem. What did we do? We have developed a model that can detect ball hits from audio signal. And how did we do that? Well, we have trained CNN on multiple images. We can see that there are 25,000 examples, and those examples are created using simple heuristics to detect hits on MEL spectrograms. And basically, it's just detecting 1 second when the ball hits occur using audio signal. So after we have done that, yeah, our model has 95% accuracy. And it's an estimated accuracy because we didn't label all matches. So we can only estimate that, and we estimated that using sampling. And now we remember that we have annotated some rallies manually. And then we have extracted some ball hits timestamps. Now we want to pair those two to get data set. So how do you do that? Well, if you have a rally with five strokes, and you detect 5 ball hits in that specific interval, you can just say, okay, I labeled this with a backhand, and the stroke occurred then. This is a backhand, and just do that for all points, and for all intervals, and for all ball hits, and then you get like a big data set, which you can use later. Okay. We have 4 classes of videos: forehand, backhand, serve, and other. Other is whatever behavior of a player which is not representative of a class forehand, backhand, and serve. So it's a player just moving around, running, standing, whatever. Yeah, as I said, we want to transform videos into action images. Now, those action images are created using, first we have estimated poses on all those videos, and then all those poses through time gives us this image. So we can see that this image is of a resolution of 25 by 18. 25 is the number of frames we employ this model, and 18 is our pose key points. So like a head, right, left shoulder, elbows, or whatever. 18 crucial key points to detect, to recognize a stroke. And we have done that by using idea from a paper, skeleton-based action recognition, using translation scale, invariant image mapping, and multi-scale deep CNN. After all this processing, we are left with 4,000 action images. Of course, we can add more, but we are left with these 4,000 at the moment. And 4 classes, again, I won't mention those names again. Bottom player, we have developed a separate model for a bottom player and for a top player, because the behavior of a player is different. And as expected, the bottom player's model works better because it's closer, the player is closer to the camera, and hence there is more information to the model. There are a lot of room for improvements. You remember 95% accuracy of audio ball detection model, ball hit detection model. We can add more images, and there are a lot of room for improvements. We just use simple CNN again to classify those strokes. Now to core detection. We first start with a bit of distorted image, and then we need to undistort it with some formula. And after we have undistorted it, in order to get straight lines, we then detect lines, classify them into vertical and horizontal by using their angles. We merge those lines, and then we try to detect a court using those lines. And how do we do that? Well, we know the proper measures of a tennis court, and it is defined by ITF, International Tennis Federation. So we use all those measures and those ratios to try to project this tennis court on our tennis court. And this is a procedure. So first we calculate intersections between all horizontal and vertical lines, and we are left with we want to get all valid candidate groups of 4 points, because we can define a tennis court by using only some 4 points. And we can see which 4 points exactly. So there are 12 court configurations. Each of those configurations can define a tennis court. So now we need to find optimal perspective transformation matrix using those 4 points. We use 4 points of those from those groups, and then we transform those points into this already defined court. And then we find the perfect candidate with using, once we obtain the group of 4 points and find a proper candidate, we then overlay some court on the image. And then once you get that skeleton of a court, you analyze all lines and actually count the white pixels on that skeleton. If there is more than some threshold of white pixels, we pronounce that for a court, like many white pixels, meaning many pixels of a line. Yeah, I hope you got that. And average accuracy for this procedure is about 97%. Once we obtain the tennis configuration, tennis court configuration, we can move move out some content from those frames, and then we run person detector using YOLO version 3 to detect players, to detect the bottom player and to detect top player, and then we follow them during the match. So yeah, we can see that here, we saw that earlier. I will move on. For ball tracking, we employed TrackNet, developed by YC Huang, and it worked pretty well, and we have just used this open source code in our research phase, and we were really satisfied with the results we got. So we should move on to the next topic, which is a ball bounce detection. So once we obtain all those positions of a ball, we wanted to detect when the ball bounces, when the ball is hit by a player. We also do that by using audio signal, as you remember. But in order to detect a bounce, we needed to simplify to the ball trajectory and to find some situations where the angle is changing appropriately. We find all those candidates. We discard bad ones, again using simple heuristics by using like a common sense or physics. And by using this procedure, we can also detect whether it was a cross-court or an inside-out shot. Because if you play it from this side there, it is obviously a cross-court shot. So, okay, we now employ all these methods we have implemented to segment non-professional match. And we did this by first finding 4 most frequent positions of a tennis player. And those 4 most frequent positions are positions where the player serves or returns the serve. And if the player lingers around those positions enough, we pronounce that a segmentation candidate. And we split those candidates into 2 groups, return candidates and serve candidates. Return candidates are obviously those left and right points, and for serve we have those middle ones. Now how we pronounce which is a positive candidate and which is a negative candidate. Well, positive candidate is the one when the serve occurs. So if there is a serve, we pronounce that as a positive candidate. As you can see on the negative candidate side, the player just lingers around doing nothing or walking. And now we fragment that candidate, which can be 10-second video, 7-second video, whatever. We fragment that candidate into multiple overlapping 1-second videos, as you can see here. And we classify all of those 1-second videos, and we try to find whether there was a serve. And you can see here that there was a serve into separate moments. So in this candidate, we actually have two serves happening. So it is a first serve and a second serve, obviously. And to classify candidates from the top player, we employ models for a top player. To classify candidate for a bottom player, we use a model for a bottom player. And with that, we're back again at this video with the projection cord on the side. This projection cord can really help us to get some inferred statistics from the full match, because we know where the ball bounces, we know which player prefers which style of a game, and we know who hit what, and yeah, it can really help analyzing stuff. To summarize all this, we saw that we are able to segment professional matches using OCR, but also we are able to segment non-professional matches using some action recognition methods. And also we saw that at the end that we can use these action recognition methods also to get some derived statistics. And again, improvements, there is always room for improvements. So that is that. And if you have some questions, I would gladly answer them.
Thank you for the presentation. My question, do you work with any tennis academies players or tournaments, providing the data, any tactics or something like that? Yeah,
we're currently at the process of like putting the stuff in a proper place at the moment for that specific question. And we have also some other things going on. So yeah, I hope soon we will have like a proper tennis academy using this system. It is with a great hope. Thank you for your question.
Hi.
Hello.
Thank you for your presentation. I'm having a similar question. What is the target audience that you want to push this product for? Is it just the academies players, or you maybe have a mind that some, for example, betting companies might adapt your product?
Which company, sorry?
Like a betting companies
Okay,
or things like that.
Yeah, well, it can also be a way of using this software, but we are currently mostly focusing on giving the players opportunity to analyze their game, and it can be used, like you said, in academies. It can be used by some non-professional players, like recreative players, and it is our target audience at this very moment. So using this to improve the game of tennis. And also, you know, there are countless possibilities for this, I guess, also in every sport. I mean, like automatic analysis can really help a lot to get some aggregate statistics and stuff. So yeah, we will see.
Thank you.
Thank you.
Thank you, Mladen.
Thank you.
Here is a certificate of appreciation for you.
Thank you. You're very kind.
Well, I believe that you enjoyed in these 3 days of conference. I'm inviting you to go to the